Hey everyone, in this video I'm going to show you how I use the Terraform to deploy two EC2 instances into an existing VPC, one in a public subnet and one in a private subnet. We'll go through the HCL code step by step, understand what each component does, then apply it, test the connectivity between the two instances, and finally clean everything up. This builds on the network infrastructure we created in one of the previous videos, and the code is run from the Terraform Linux machine we set up in a separate video. First, I'll create a dedicated directory for this project on my Linux VM to keep our Terraform files organized. Now I am pulling the HCL script directly from my GitHub repository. Using wget is the fastest way to get our code onto the local machine where Terraform is installed. I put the download link for this script in the description below. Now let's look into the code and see what it does. The first part is the provider block. This tells Terraform that we are working with AWS. It uses credentials configured on this machine, typically via the AWS CLI or environment variables are explained in the Terraform setup video. Nothing complex here, but it's required for Terraform to know which API to talk to. Next, we define two data source blocks to dynamically fetch the latest AMIs. The first block queries AWS for the latest Amazon Linux 2023 image. The second one is Canonical's official AWS account ID. So we are pulling a trusted Ubuntu image. Below AMI blocks are VPC and subnet resource blocks where things get interesting. We are not creating a VPC or subnets. We reference our existing network infrastructure using data sources. This is a key Terraform concept. Where resources already exist in AWS, we use the data keyword to look them up rather than recreating them. We are looking up the VPC by its name tag, up 24/7 VPC, and doing the same for the public and private subnets. Terraform will query AWS, find the matching resources, and make their IDs available for us to reference later in the code. Similarly, we look up two existing security groups, one for the public host and one for the private host. Notice here we are filtering by group name rather than a name tag. This is because these security groups were pre-existing ones without a name tag, just a group name, so filtering on tag name would return no results. Something to watch out for when your AWS resources aren't consistently tagged. Here we create an SSH key pair resource in AWS using our local public key file. Terraform reads the public key from the default SSH location on the machine running the deployment and registers it with AWS as an Ansible key. This key pair will be attached to both EC2 instances, allowing us to SSH into them. Now let's look at the first EC2 instance, the public host. It uses the Ubuntu AMI we looked up earlier, a T3 micro instance type, and gets placed into the public subnet with the public host security group attached. What makes this instance interesting is the provisioner block. After the instance is created and SSH becomes available, Terraform opens an SSH connection using the Ubuntu user and our private key, and copies our local private key file directly onto the instance. It then runs a remote command to set the correct file permissions, chmod 600, so the key is locked down properly. Why do we copy the private key onto the instance? Because the public host will act as a jump box or bashing host to reach the private host in the private subnet. It needs a private key to SSH forward into the private network. Finally, the user data script sets a host name to public host at first boot, and we tag the instance with the same name, so it's easy to identify in the AWS console. The second instance is a private host. This one uses Amazon Linux 2023 instead of Ubuntu and gets placed into the private subnet with its own security group. Notice there are no provisioner here. This instance isn't directly reachable from the internet, so we can't SSH into it directly from our local machine. Access goes through the public host we just set up. The user data sets the hostname to private host, and we tagged it accordingly. Finally, the output blocks. These are printed to the terminal after Terraform apply completes. We are outputting the instance IDs and the public IP of the public host, and most usefully, the exact SSH command to connect to both instances. For the public host, it's simply SSH into the public IP using the Ubuntu user. For the private host, notice the SSH command uses the private IP address and the EC2 user account. That's the default user for Amazon Linux. You'd run this command from inside the public host, not from your local machine. Also notice the public DNS output is commented out. That's fine to leave in as a reference for later if you need it. That's a full Terraform configuration. To deploy this yourself, make sure your AWS CLI is configured, your SSH key exists at the default location, and your VPC infrastructure from the previous video is already in place. Then it's just a Terraform init, Terraform plan to review, Terraform apply to deploy, and Terraform destroy to take them down. If you find this useful, hit like and subscribe for more cloud networking content. Now let's see it in action. We start with the Terraform init. This initializes the working directory and downloads the required provider plugins. You can see Terraform reaching out to the HashiCorp registry and installing the AWS provider, version 6.41.0 in this case. Once that's done, we are ready to plan. Running Terraform plan, the first thing you'll notice is all the data sources being read in parallel. Terraform simultaneously queries AWS for the Ubuntu AMI, the Amazon Linux AMI, the VPC, both subnets, and both security groups, all at the same time. Within few seconds, all the lookups complete, and we get back the real AWS resource IDs. These are live IDs from our actual AWS account in CA Central 1 region. Terraform has identified the 3 resources to add: our key pair, the public host, and the private instance. Before we hit apply, let's verify our current state in the AWS console. As you can see, there are currently no running instances in the Canada Central region. Back in the terminal, we'll run Terraform apply. This is the moment where our configuration becomes actual infrastructure. Terraform prompts us for confirmation. After reviewing the plan one last time, we type yes to begin the provisioning process. You can track the progress in real time. It's creating the Ansible key first, followed by our public and private EC2 instances. This usually takes about 30 to 45 seconds. And we are successful. Infrastructure is complete. Note the outputs here. Terraform has provided the public IP for our jump host and the internal private IP for the private host. Refreshing the AWS console now, and there they are. Both instances are initializing and passing their status checks as expected. A quick jump over to the key pairs section confirms that our Ansible key was also successfully imported via the Terraform resource. As the two instances are still initializing, we refresh our browser a few times. Now both instances pass the status check. To test the connectivity, I've started a pin to the public IP. We're getting a solid response, which means our security groups and the internet gateway are routing traffic correctly. I'm using the SSH command provided in our outputs to log in, and we are now officially inside the Ubuntu environment on our public host. I'm scrolling up to get the command for connecting to the private host, as we will do shortly. But before we do that, let's check the .ssh directory. And there it is, two files. Authorizer keys, which was set up by AWS with our public key, and the ID RSA, the private key that Terraform copied over using the file provisioner, locked down with 600 permissions. The bastion host is fully configured. Now for the real test, reaching the private instance from the public one. This confirms our internal VPC routing and the private subnets are functioning. Since this is a lab environment, I want to avoid unnecessary costs. So I'll run Terraform destroy to tear down the entire stack in one command. As you can see on the screen, data sources are reread to get the current state. Then Terraform presents a destroy plan. 3 resources to remove, all marked with the minus signs. The 5 outputs will also be cleared. We type yes, and both EC2 instances start terminating simultaneously. Another key pair will be deleted as well. The VPC, subnets, security groups, all the infrastructure we referenced via data sources, those remain untouched in AWS exactly as expected. Terraform only destroys what it created. Destroy complete. 3 resources have been destroyed exactly as we expected. One final check in AWS console. The instances are now terminated. The key pair is also gone. Everything is cleaned up. The whole thing from 2 running instances back to nothing in 30 seconds. And if I need the 2 instances up again, I just need to run Terraform apply. That's the power of infrastructure as code. Repeatable, predictable, and fully reversible. The source code is in the description. Please don't forget to hit like button and subscribe. See you in the next one.